We're going to continue today talking about ionic compounds. But along with our ionic compounds, we're going to also include something called polyatomic ions. Poly means many, so a polyatomic ion is a tightly bonded group of atoms with a positive or negative charge overall. Let's look at something called the ammonium ion. NH4 plus 1. So what that means is you have a nitrogen and 4 hydrogen atoms, and they come together and they form a bundle. 1 nitrogen atom and 4 hydrogen atoms form a group or a bundle, and together that group has a positive 1 charge. So it's not that the nitrogen is plus 1 or the hydrogens are plus 1, but together the entire group of atoms has a plus 1 charge. So the group lost an electron. Let's look at nitrate ion. Nitrate is NO3 minus 1. So what that means is 1 nitrogen atom and 3 oxygen atoms come together and they form a group. NO3 is a group of atoms. And then together, that group gains an electron to take on a minus 1 charge. It's not that the O is minus 1 or the N is minus 1, but together, the group of atoms is a minus 1 charge. Same thing, we can look at sulfate down here. Sulfate is 1 sulfur atom and 4 oxygen atoms, and the group together gains 2 electrons to take on a minus 2 charge. So when we look at how it's written, I know that the 2 looks kind of like, well, it's written next to the O's. It doesn't go with just the O, it goes with the entire group. So sulfur atom and 4 oxygen atoms, and then the group is the minus 2 charge. Same thing over here, phosphate ion. That's 1 phosphorus atom and 4 oxygen atoms, and together the whole group takes on a minus 3 charge. So the group gains 3 extra electrons. Okay, so I know it looks like the 3 is written kind of by the O, but it doesn't belong to just the O. That charge belongs to the entire group. Here's a list of common polyatomic ions. There are more than this, but these are the ones that we are going to look at the most. And so they're arranged by charge. Everything in that first column set has a minus 1 charge. Dihydrogen phosphate, acetate, hydrogen sulfite, hydrogen sulfate. Oh wait, hydrogen sulfite and sulfate. Some of these names sound really similar and they might just be different by 1 atom. So this one is SO3, but this one is SO4. So be careful. They sound an awful lot alike for some of these, but they might be different by an atom or such. And if you go a little bit further down, we have nitrite and nitrate. We have hypochlorite, chlorite, chlorate, and perchlorate. They get kind of confusing, but if you look, subscript of 1, subscript of 2, 3, and 4. Some of them sound really, really similar, so be careful. The second column, those are all of your polyatomic ions with a minus 2 charge. Hydrogen phosphate, oxalate, sulfite, sulfate. Once again, we start to have very similar names, sulfite and sulfate. SO3, SO4, both with a minus 2 charge. Okay. Third column, those are your minus 3 charges. Phosphite and phosphate. And then we have arsenate. And so you might be thinking, these are all negative charges. What about positive ones? We have 1 positive one down here in the corner. Ammonium, NH4 plus 1. Okay. How are we going to name these? Same thing applies to our rules for the other ionic compounds that we were doing. You should see a first part and a second part, a positive piece and a negative piece. So in this first one, here's your first part, And here's your second part. And getting to know those polyatomic ions is going to be really important so that you can identify a first part and a second part. Because if you don't recognize the PO4 as one big group, you might be inclined to call it phosphorus oxide, when in fact it's actually called phosphate. It's a group. So it's going to be really important that you get to learn those polyatomic ions pretty well. So again, we have our first part and our second part. If we were to break this up into its individual ions, because we know we should have two ions in there, positive ion and a negative ion, we would have Ca plus 2 as our positive ion and PO4 minus 3 as our negative ion. Okay, so calcium and then phosphate. Same rules apply. We're going to name each ion, although this time we're not going to change any of the endings. So if you remember, we had been changing the ending of the negative piece to IDE. Well, if you see a polyatomic ion, those are the ones on that table that we just looked at, you just name it whatever the ion's name is. Okay, so just name each ion, no changing of endings. So we're going to call this calcium phosphate. Name the first part, calcium. Name the second part, phosphate. So it's so important that you're able to recognize those polyatomic ions. Even though they're bigger, it's still just one ion. All right, our second one. Let's look. We should be able to see a first part and a second part. So we have a positive piece and a negative piece. Okay? If we were to break it up into its ions, NH4 plus 1 and SO4 minus 2. So we do have positive and negative, but this is really positive 1 and negative 2. But still a positive coming together with a negative to balance out to be electrically neutral. Okay, so name the first part, ammonium. Name the second part, sulfate. Just name them. No changing of the endings to IDE. But again, I can't stress enough, it's so important that you are able to recognize these as just bigger ions so that you're not trying to name each individual piece like nitrogen, hydrogen, sulfur, oxide. That would be way too much. There's only two parts, first part, second part. Don't forget, we still might need some Roman numerals in there. Let's do this one. PbNO3, 2. So we've got a first part and a second part. Remember, don't worry about these little subscripts, like the 2. It doesn't matter for the naming. We'll get to that for formula writing in just a bit. But first part, second part. Lead, right down here, is that in that group that needs a set of Roman numerals? Yes, it's a transition metal or tin or lead. It's lead. So look at nitrate. If you look on your chart, nitrate, NO3, has a charge of minus 1. We have 2 of them. Here's 2 of them. 2 doesn't matter for the name, but it will help us figure out what the charge on the lead is. So we know we have an NO3 minus 1 and an NO3 minus 1 to give us a total of minus 2. And so what does the lead in the front have to be in order to balance that out? It's got to be a plus 2. So your one lead has to be a plus 2 to balance out the 2 minus 1 nitrates. So we would call this lead 2 nitrate. Now, what if we went backwards and did formula writing? Well, this is the same as it's always been. Remember, we're going to write our 2 ions out first. And I know that the ions are a little bit bigger right now, but that's okay. We're still going to write our 2 ions out first. So potassium arsenate. Potassium we know is a plus 1 charge. It's in that first column. Arsenate is one of these new polyatomic ions, so get to know them, get to love them. Arsenate is a charge of minus 3. You'll find it in that third column over. So here we've got our 2 ions. Same thing applies. Crisscross. Your 3 is going to go down by the K, and the 1, which we're not going to write, is going to come down as a subscript for the arsenate. They still have to balance out though. So if we had 3 positive 1 potassiums to balance out the 1 phosphate with a -3 charge, we would have K3ASO4. Potassium, here's potassium, and then your arsenate. +3 to balance out a -3. Magnesium hydroxide. So let's write our 2 ions out first. Magnesium we know is a +2 charge. Hydroxide is one of these polyatomic ions. You'll find it in the first column. That has a -1 charge. So they still need to balance out to 0. You will need 2 hydroxides to balance out 1 magnesium ion. So how do we actually do this? Let's look at our crisscrossing. So if we had Mg +2 and OH -1, cross the 1 down here and the 2 down here, and so that would give us MgOH2. But what's the difference of MgOH2 and Mg parentheses OH parentheses 2? Remember that your polyatomic ions, it's a group, it's a bundle, and so the OH stays together. If we wrote this first way, we would be saying O with just 2 H's, right? The 2 would go with just the H. But I don't want just 2 H's. I need 2 groups of OH, 2 groups of hydroxide. And so if I use parentheses and put the 2 outside the parentheses, like in the second example, that would actually show 2 groups of hydroxide instead of just 2 of the hydrogens. So if you are crossing your subscripts down and you find that you need more than one group or more than one polyatomic ion, that's when we're going to use parentheses. If there is more than one of a polyatomic ion needed, use parentheses. So our formula for this one is going to be Mg parentheses OH2 to show that we need 2 groups of OH and not just an O and 2 H's. All right, iron 3 chlorate. So the first thing we're going to do is put our 2 individual ions with their charge. I know it takes a second, but it's going to make things much, much easier if you take the time to write your 2 ions out. So iron 3, how did we get the +3? Remember that the Roman numeral, that is the charge of that transition metal. Yep, iron's a transition metal. That's why it has the Roman numerals. And then we have chlorate. That is one of these polyatomic ions. You'll find it in that first column, ClO3 -1. So here's our 2 ions, and we're just going to cross our numbers down just like we had in the past. So the 1 comes down with the iron, the 3 comes down with the chlorate. Be careful. We're going to need some parentheses here because that's a 3 that's crossing down. If I don't use parentheses, I'm going to end up with ClO3, 3. I'm going to end up with 33 O's. Super important that I end up using parentheses. Same thing though, that we have to balance out to 0. 3 of the chlorates to balance out 1 of the iron. +3 -3. So with parentheses, when I cross that 3 down, I end up with Fe parentheses ClO3 parentheses 3. Otherwise, I've got 33 O's if I don't use parentheses. So let's take a second. I really need to do this. So the 3 that's right here on the inside of the parentheses, that one goes with the O. The 3 that's on the outside of the parentheses, that goes with the group. So be careful of what's in the parentheses and what's outside the parentheses.